These are our solutions to 2024 CCEA GCSE Further Maths Unit 1, which is the pure mathematics module, and you're allowed a calculator with this one. So just how we look here on the paper, it says 2 decimal places you have to go to. So we'll have to remember that throughout. Try to. Okay, you get a number of formulas. You get quadratic equation, differentiation, integration basics, log rules. The 3 log rules, very important. And then matrices as well, a wee bit of information about matrices, the determinant, and how you find the inverse. First question, it says, find an expression for, it says, given that dy by dx is equal to 6x squared minus 2 over 5x squared plus 4, find this expression for d2y by dx squared. Now, the first thing I'm going to do is write my dy by dx in index form. This term is fine, it was already there. This one, right, is 2 over 5 times x to the minus 2, and then plus 4. How you get your d2y by dx squared, it's what's called a second derivative. You get it by differentiating your dy by dx with respect to x. So if I do that, I'm going to get 12x, that's multiplying by the power, reducing the power by 1. Now if I multiply minus 2 over 5 by minus 2, I will get plus 4 over 5, and reduce the power by 1 goes down to minus 3, and 4 differentiates just to give you 0. I would just write this in the form that they had it. So I'll put the 4 on the top, and on the bottom goes 5x cubed. And that's it, 2 marks. Next one says find an expression for y, given that y is equal to 4 when x is equal to minus 2. Now, how you get back to your y, if you have your dy by dx, which we originally had, is you integrate your dy by dx with respect to x. So your dy by dx was 6x squared, there we are, we'll use this version here, minus 2 over 5 x to the minus 2 plus 4. So we're just going to be integrating that. So 6x squared minus 2 over 5 x to the minus 2 plus 4, that's our dy by dx. We're going to integrate it. So if you integrate it, you're going to get, and I'll just show all my steps here, 6x cubed over 3, raise the power by 1, divide by the new power, minus 2 over 5, raise the power by 1, divide by the new power, and then plus 4x plus c. Let's tidy that up, it's a bit of a mess. That's 2x cubed. This will then be plus 2 over 5x, then plus 4x, and plus c. It tells us when x is equal to minus 2, y is equal to 4, which means 4 is equal to, that's going to be 2 times minus 2 cubed, plus 2 over 5 times minus 2, plus 4 times minus 2, plus c. And do a bit of working out then. Bring that all to the other side. 4 minus all of those things, and you're going to get your c works out to be 28 and 1/5. And your answer then, y is equal to 2x cubed, plus 2 over 5x, plus 4x, and plus 28 and 1/5. Next question says, solve the equation x squared plus 14x plus 10 is equal to 7 by completing the square. Give your answer in surd form. So to do this, what we want to do, I like to isolate my 2x terms. When I say my 2x terms, I mean my x squared term and my 14x. And just that's all I'm doing here at the start. And then I want to complete the square in this bracket. So you half the coefficient of the x. So the coefficient of the x is 14. Half of that then gives you plus 7. So that's what that becomes. But that means you have got an extra 7 squared term. So you've got to remember to take that off. So that's what you've got. So then that becomes x plus 7 squared. And then we'll just tidy that up then. You've got 7 minus 10 minus, but it'll be plus 10. 7 squared when it goes across, which means x plus 7 all squared equals 46, if I've done that correctly. That looks right, 49. Let me just check that, sorry, 49 minus 10 plus 7, yes, 46. And then that means my x plus 7 is equal to plus or minus the square root of 46. And then your last line, your x is equal to minus 7 plus or minus the square root of 46. And that's as good as you can go. And that's the answer in surd form. Lovely. Question 3. Solve the inequality. X plus 1 squared is greater or equal to 2x plus 5. Okay, write this out, and I've said time and time again, write that out the long way, as I've seen far too many times very good mathematicians make mistakes on this. So x times x is x squared, x times 1. X times 1 is x, you have another x here, so that's going to be 2x plus 1 is greater or equal to 2x plus 5. Oh, very nice. And that one actually works out very, very nice. You can cancel the two x's on both sides and bring that 1 across. You'll have x squared is greater or equal to 4. Now, this is the easiest way to do this question. You can do this one without any graphs. I'll show you another way of doing it if you don't spot this. But because it's just x squared is greater than or equal to a number, you can just say, take the positive square root. Positive square root then would be plus 2, or the negative square root would be minus 2, and you change the direction of your inequality. Okay, now that's the best way of doing it. Let's just look at a different way of doing it. So we'll go from this line here. If I brought my 4 across, I could also use the difference of two squares. Okay, that should be a plus 2. And then that means it's going to be equal to 0 when x equals 2 or when x equals minus 2. You could then do it's a positive quadratic, so it's a U-shaped graph. It crosses at minus 2 and plus 2. We want it to be greater than 0, so I want it to be this way or this way, which again gives you x is less than or equal to minus 2 as we had above, or x is greater than or equal to 2 here. But just because this one worked out nicely, you could have done it that easier way. But if it's a slightly harder one, or you don't spot it, you have to just bring it all to one side, factorize, find where it equals 0, and go from there. Okay, next question says, solve the equation. It was cos of x is equal to minus 0.6, and cos x equals minus 0.6. So you do your basic angle, and how you do your basic angle, you do cos to minus 1, you ignore the minus, and you just do that. And if I've done that correctly in my calculator, that's going to be 53.130 degrees. Notice I've just gone to my third decimal place because my answers needed to be corrected 2 decimal places. It was 0 to 180. I only ever really would mark on the 0, to be honest, but just for the sake of it, I'm going to mark on that would be 90 degrees, 180 degrees, minus 180, and minus 90 here. So its cos is negative, so it's going to be in here or in here. So that's my angle. What was it? 53.130, 53.130. That's one of my answers, and that's my other answer. So here, my answers are going to be plus or minus. They're both the same, except one's the negative of the other. And it would be 126.87 degrees to 2 decimal places. Okay, right. Next one says, hence solve. And they've done the same thing, except they've changed the angle. So the first thing we're going to do is change this. So underneath my theta, I'm writing theta over 2 minus 20. And you have got to think then, how do you get from theta to theta over 2 minus 20? So what you do, and the order is important, you divide by 2 first, and then you take away 20. So if you do 360 divided by 2, you get 180, take away 20, you get 160. Do the same, divide 360, minus 360 by 2, you get minus 180. Take away another 20, that's minus 200. And that means from earlier on, our two angles are equal to this. But it's theta over 2 minus 20 equals, it was a minus 126.87 or plus 126.87. So add 20 to both of those first of all. You'll have minus 106.87 and 146.87, and then multiplying them both by 2, minus 213.74 degrees, or 293.74 degrees. Okay, next one says find the inverse of P. And so that's what we've got to do here. Let's just write down what's our P. P is equal to 2, 1, 4, 3. So P is equal to that. And your first thing you want to do is find your determinant. Determinant of P is equal to the product of the leading diagonal minus the product of the other diagonal. So that's going to be 6 minus 4, which is just 2. That means your inverse of P is 1 over 2. Switch the elements in the leading diagonal, switch the signs of the other elements. Okay, and that's it done. Lovely, 2 easy marks. It says, hence find the matrix N such that Px is equal to Px equals Q, and you want to find your matrix X. Right, I'm not going to write down any matrices for a wee second here. I'm going to put this down. What you do in matrix multiplication is you want to put your inverse of P in front of the X. That gets rid of the P, because it becomes then I times X, which then just becomes X. But if you put the inverse of P in front on the left-hand side, you must put the inverse of P in front on the right-hand side. Okay, so that's what we're going to do here. So Xn is equal to our inverse of P. And if I've copied that down correctly from earlier on, that's what it was. Let me just check that. 3 minus 1 minus 4, 2. Yep. And then our Q, where was Q? Q was 4, 6. So 4, 6. Okay, this is going to be tricky to explain here. Do a couple of steps to get to our answer. Okay, first of all, you've got a 2 by 2 matrix. That's the order of it, because it's got 2 rows and 2 columns, and then this is a 2 by 1. So my result is going to be, take the outside things. First of all, they're compatible because the 2 inside numbers are the same, and then the result is going to be the 2 outside things. So it's going to be a 2 by 1. So it's going to be a column matrix like we had here. And how you do this then, it's going to be a 2 by 1. This first element, how you get it, is you think about its location. It's first row, first column, which means you multiply the elements in the first row by the elements in the first column. So 3 times 4 plus, then minus 1 times 6. And if you do that, if I've done that correctly, and that's right, here. 3 times 4 is not going to be that. It's not going to be that, sorry, apologies. 3 times 4 is going to be 12, and then minus 6 is just going to be 6. And then this one is going to be the second row times the first column. And that's going to be, what's that going to be? Minus 16 plus 12. So minus 16 plus 12 is just minus 4. And then we multiply in by the half. Half times 6 is 3. Half times the 4 is minus 2. Okay, so just be very careful on those. And when I was looking at my working out there, I realized I made a mistake in the top one. So just be very careful on those questions. Okay, next one. What have we got here? Logs. Lovely. Okay, write as a single log. Now your 3 rules of logs, which are on the formula sheet. First thing is that we're going to use rule 3, which is n log x is equal to log x to the power of n. So this 3 comes up here and is powering the 2x. And same idea here, that's going to be log x squared. And then let's just tidy that up. That's going to be log of 8x cubed minus log of x squared. Using my second rule of logs, which is log of a minus log of b is equal to log of a over b. So that's going to be 8x cubed over x squared, which is going to be log, and that's just going to be 8x. That's as good as we can go. Okay, solve the equation. And this is a log equation here. So you take logs of both sides. You'll have 2x plus 1 times log of 4 is equal to 3x minus 2 in a bracket times log of 6. Multiply out, you'll have 2x log 4 plus log 4 is equal to 3x log 6 minus 2 log 6. Bring all the x's to one side. And fire everything else over the other side. Then we want to factorize. So pull an x outside of brackets here. And then your last bit of ugly working out is that whole right-hand side. Sorry, that whole right-hand side, which was minus log 4 minus 2 log 6 gets divided by the bracket. Let me just check. And then you fire that into your calculator. And hopefully I've done that right. I have got that to 1 dp. So didn't use my calculator until the very end there. Definitely the nicest way of doing it, and most accurate way of doing it as well. Okay, right, matrices again. It says the matrices A, B, C are defined by A, B, and C are as follows. Calculate B minus 2C. So you're doing 2 minus 1 minus 1, 0, minus 2 times the 1, 5, 0, 3. So that's going to be 2 minus 1 minus 1, 0, minus, and that's going to be 2, 10, 0, 6. And if you fire that in, 2 minus the 2 is 0, minus 1 minus 10 is minus 11, minus 1 minus 0 is minus 1, 0 minus 6 is minus 6. And that is all it is, 1 mark. Next one is to find A squared. To find A squared is going to be A, which was that, times A again. So again, let's just look at what we've got. We've a 2 by 2 by a 2 by 2. So it's compatible, first of all, because the two inside numbers are the same. And the order of the result is the outside. So that's what you're going to get. You're going to get a 2 by 2 as the result. Okay, so when you do that, to get your first row, this element here is first row, first column. So I'm multiplying the 4 times the 4 and the 5 times the minus 1. So 4 times 4 is 16, 5 times minus 1 is minus 5, 16 minus 5 is 11. To get this element here, it's first row, second column. So the first row times the second column. So 4 times 5 is 20, and 5 times minus 1 is minus 5. 20 minus 5 is 15. This element here is second row, first column. So minus 1 times 4 is minus 4. Minus 1 times minus 1 is plus 1. Minus 4 plus 1 is minus 3. And then here, minus 1 times 5 is minus 5. Minus 1 times minus 1 is plus 1. Minus 5 plus 1 is minus 4. And there we have it. Oh, here we go again. More matrices. Find the value of A, B, and C in the following matrix equation. Okay, right. They're really testing this multiplying matrices in this exam. Right, find the values of A, B, and C. So to get, we're just going to go through it and think, how do we get all of these different elements? So, which one did I start with? I think I did this one first. I'll just put a wee 1 here to show which one I'm doing first. That's what I did first. And what I did then, it's the first row, second column. So you do your first row times your second column. And that gave me 4. So that just gives you 2b is equal to 4, which means b is equal to 2. So I've got that straight off. And then the next thing I did, sorry, let me just write up what I'm doing here. That was like number 1. The next thing I did then, I did this one. So that was the second thing I did. So that is my second row, second column. So you do your elements in your second row times elements in your second column. No, sorry, that should have been second row times second column. So it should be A times 4 plus 1 times 0. And that gave me 6. So 4a is equal to 6. A works out to be 1.5. And the last one I'm doing here is this one. So to get that last one there, that C is equal to my that's my second row, first column. So that's my A times 4 plus 1 times minus 5. So 4a minus 5 is equal to C. And we know our A was 1.5. 4 times 1.5 minus 5 then is equal to C. 4 times 1.5 is 6. Minus 5 then, my C is equal to 1. So you've got your A is equal to 1.5, your C is equal to 1, and your B was equal to 2. That's your answer. Tricky enough question. Hopefully that's the end of matrices. I think we have done enough matrices in this paper. We'll soon find out. Okay, question 8. Question 8, we've got simplify fully the following algebraic expressions. Okay, factorize everything. So top line, 2x comes out, leaving you x plus 3. Bottom line, and this is where people will forget this, difference of two squares, it's x minus 1 upon x plus 1, divided by 4 comes out, leaving you x plus 3. And this bottom line factorizes. I'm going to omit the working out, but this is a sum and product method. And that's what you're going to get when you do the sum and product method. Okay, and then let's flip your dividing fraction. We've done the hard bit here by the factorizing. Flip your dividing fraction becomes a multiply, and the dividing fraction flips as well. And then you've got 4 times x plus 3. And then nice neat line. Don't be scoring things out like this. Just put a nice neat line through them, please. So you can see, I'll use a different colour just so you can still see it. X plus 3 and x plus 3 cancels. Then I'll go in red. I have an x minus 1 and an x minus 1 cancel. What else have I got? That's maybe it, is it? Yep, I'll go on here and I'll write that as 2x times 2x plus 5 all over 4 times x plus 1. And then notice as well, the number terms cancel down, I should say. So that's just going to be 2 times x plus 1. And that's it. Lovely. Very nice question. Okay, another nice one here. If you don't enjoy this, you're doing the wrong subject. We've got x over x plus 3 plus 2 over x squared minus 9, then times x plus 3 over x minus 1. Okay, right. BIDMAS or BODMAS, whatever way you do it, would tell you want to sort your bracket out first. So we're going to do that as well here. So we're going to have to take a common denominator. Now factorize before you do that, and you'll see you have x plus 3, x minus 3. If you don't spot that, folks, this gets very tricky very quickly. So your common denominator inside this bracket just has to be x plus 3, x minus 3. So that thing over here, that plus 2 is already sorted. This x just needs to be multiplied by x minus 3. And then you're multiplying by x plus 3 over x minus 1. Now let's just put those in a bracket. It makes it a wee bit easier to see our cancelling. And I would cancel on this line. I have an x plus 3, nice neat line through it, and a neat line through that. So that cancels down. Doesn't go to 0, it goes to 1. So x plus 3 divides into it 1 times. Likewise, that really becomes a 1, but you don't need to write it. Okay, let's tidy up. Top line is going to become x squared minus 3x plus 2. Bottom line still x minus 3. And that's times 1 over x minus 1. And this thing over here, this top line, I'll do it in yellow. It factorizes, so now factorize it again. It's going to factorize to be x minus 1, x minus 2, all over x minus 3 times 1 over x minus 1. And what cancels again? X minus 1 cancels, leaving you just x minus 2 over x minus 3. Lovely. Okay, where are we on to now? Question 9 of what seems like 100 questions. Right, it says, at a point P, where x equals minus 1, the tangent to the curve is parallel to the straight line y is equal to 3x plus 1. This thing here has a gradient of 3. So, tangent, when you see the words tangent, normal, turning point, gradient, maximum, minimum, stationary point, any of these words, you want to be thinking dy by dx. So I'm going to differentiate this thing over here. So first thing I'm going to do is write it in index form. Then I'm going to differentiate it. And I'll just get minus 2ax to minus 3. So that was multiplying by the power, reducing the power by 1. And then it says at the point P, where x equals minus 1. So I would just say when x equals minus 1, our dy by dx is equal to minus 2a times minus 1 to minus 3. So that's minus 2a times minus 1, which is just going to be 2a. So the gradient at minus 1, the gradient of the tangent is 2a, but we also know the gradient of the tangent is equal to 3. So we're just going to say put 3 equal to 2a, which means a is equal to 1.5. Lovely. Find the value of a, and we've done it. It says, find the equation of the tangent to the curve at the point P. Okay, so we know already that the gradient at the point P was equal to 3. Okay, therefore our tangent so far is y is equal to 3x plus c, because that's your y equals mx plus c equation. Also, we've got to find the corresponding x value. So when x equals minus 1, your y equals, and we're putting it back into this equation up here. So y is equal to 4 plus, instead of a, write 1.5, and it was minus 1 squared. And if you do that, let me just check that, sorry. It's going to be 4 plus 1.5, it's going to be 5.5. Okay, and then you're going to sub the point minus 1, 5.5 into y is equal to 3x plus c. So that just becomes 5.5 is equal to 3 times minus 1 plus c, which means we better working out 8.5 is equal to your c. So your equation is y is equal to 3x plus 8.5. And I think I would leave it like that. You could multiply through everything by 2 to give you 2y equals 6x plus whatever that's going to be, 17. But I think that's fine. Okay, next one says find the equation of the normal to the curve at the point. So the normal and the tangent, their gradients are negative reciprocals, so you've got that. That means the equation of your normal is minus 1 over 3x plus c. And we knew the point that at p was minus 1, 5.5. So we're going to sub that in. So 5.5 is equal to minus a third times minus 1 plus c. So 5.5 is equal to 1/3 plus c. And I just did this with my calculator, and the calculator sorts it out. Gives you a nice fraction answer. That gave me c is equal to 5 1/6. So y is equal to minus 1/3 x plus 5 1/6. And what they might want you to do, I'm not too sure, is multiply everything through by 6 to give you 6y minus 2x. And what is that going to be? Bear with me a wee second. 5 1/6 times 6. I can't believe I just did that in my calculator. That was 31. Right, how I should have done that without a calculator, but you're checking an exam. 5 times 6 is 30. 6 times 1/6 is 1, so 30 plus 1 is 31. But calculator exam, so you may as well check. Okay, right, that's the end of that question, I think. Nice question as it was. Okay, a curve is defined by the following equation. Find the coordinates of points where it meets the x-axis. So we want to put y equal to 0 then. So 0 equals 2x cubed minus 5x squared minus 3x. This factorizes. You can pull out an x first of all. And then that's going to be 2x plus 1, x minus 3. That's by doing the old sum and product. I've omitted the working out for that, but that's what it is. And then that means x equals 0, or here x equals minus a half, or here x equals 3. Right, it says find the coordinates. So a very easy mark people threw away by not writing down the answer. So the coordinates where it crosses, there you go. Okay, find the, this is a long one. Find the coordinates of the turning points of the curve using calculus and identify each turning point as either a maximum or a minimum turning point. Okay, your y, first of all, was 2x cubed minus 5x squared minus 3x. Your dy by dx, and differentiate that, you're going to get 6x squared minus 10x minus 3. To find a turning point, or whatever it is, you your 0 equal to the gradient, because at a turning point or maximum or minimum or anything of that like that, your gradient is 0. Now I did that, and I had to use my quadratic formula, and when I put that in, I got minus 0.2596 or 1.926, and then I'll say when I want to find the corresponding y values when x is equal to minus 0.2596, my y value, so just put it into the y equation up there. Don't have to show any working out, but you just put it in, and when I did that I got 0.4068. And again, we'll do the same for this one. When x is equal to 1.92, it's a 9, believe it or not, 926, y is equal to minus 10.0365. Okay, so I've got turning points, but I don't know if they're maximum or minimum, so you absolutely must do this. So your d2y by dx squared, differentiate your dy by dx function, you'll get 12x minus 10, and then just say when x equals minus 0.2596, your d2y by dx squared is equal to 12 times minus 0.2596 minus 10. You can see both those things are negative, so that's less than 0. Therefore, it's a maximum, and I would just say what the point was. So therefore, the two decimal places now, 0.26.41 is a maximum turning point. Okay, we'll do the same idea for the second turning point. So I'll just say, I remember my d2y by dx squared, I'd already worked out, I'll just write it down again. I'll just say when x equals, what was it, 1.926, my d2y by dx squared is going to be 12 times 1.926 minus 10, and that you can see is bigger than 0. Bigger than 0, therefore it's a minimum, and then your answer, therefore, 1.93 to two decimal places minus 10.04 is a minimum turning point. And the last one, I think, of this question is a sketching one. Wasting a bit of paper here. Oh, there we go, sketch the curve. So you want to sketch the curve. So our curve had, bear with me a wee second, it crossed at the origin, it crossed at minus 0.5, it crossed at 3, over here somewhere, it's just a sketch, and it had a maximum turning point. Well, here, you know what, I'll just draw it. That's roughly what it looks like, and this was our maximum turning point, was minus point, bear with me, what was maximum turning point? Minus 0.26, and then that was 0.41. Minimum turning point was at 1.93 and minus 10.04. So as long as you've got the general shape, that's the way it looks like. Crosses at 3 points, one of them being your origin, and then put your maximum and minimum on, so it's a very quick thing to do. Okay, just a sketch. This question is a simultaneous equations question. It says a car showroom sells new car models, Hurricane, Iguana and Geronimo. The profit for each Hurricane sold is X, the profit for each Iguana sold is Y, the profit for each Geronimo sold is Z, where X, Y and Z are in thousands of pounds. In February, 10 Hurricanes, 12 Iguanas and 16 Geronimos were sold. The total profit was 94,000. Show that X, Y and Z satisfy the equation. So you had 10 lots of X, you had 12 lots of Y, and you had 16 lots of Z, and that would give you 94,000. So remember, X, Y and Z are in thousands. So all you do, and these are very easy, these are divided through by 2, and you get 5x plus 6y plus 8z is equal to 47. And that was your equation 1 that we're looking for. Very easy for the next one as well. In March, you had 16 Hurricanes, iguanas, 4 Geronimos, and that was 82,000. Again, divide through by 2, just you'll get 8x plus 3y plus 2z is equal to 41, and that's going to be my equation 2. In April, 18 hurricanes, 3 iguanas, 12 Geronimos were sold. Total profit was 96,000. Divide through by 3 and you'll get what you want. 6x plus y plus 4z is equal to 32, equation 3. Okay, so you've been given a really nice way for them to ask a question, because they give you the equations so that you can't be in any doubt. And then the next bit is, it says solve these. So let's just call these equation 1, equation 2, and equation 3. And find a profit the showroom makes for each sale of each model. So you basically, it says find x, y, and z. And remember then, you put on 3 zeros for each of those because they're in thousands. Okay. I'm going to say what I want to eliminate. So I'm going to say eliminate z. So a bit of a long question, this one. So I'm going to do eliminate z by making the number of z's in each equation the same. So I'm going to multiply my equation 3 by 2, and that'll give me 12x plus 2y plus 8z is equal to 64. And my equation 1 underneath it then was 5x plus 6y plus 8z is equal to 47. Now if you subtract, so if you do 2 times that equation 3 minus equation 1, that's going to give you equation 4, which is 7x minus 4y is equal to 17. So I've got one equation here with 2 unknowns. I need to eliminate z from another set of equations as well. So what I'm going to do is I'm going to multiply my second equation by 2, which would give me 16x plus 6y plus 4z is equal to 82. And then I'm going to take away my equation 3. So I'm going to write down my equation 3. First of all, it's 6x plus y plus 4z is equal to 32. And if you subtract, so if you do equation 2 times equation 2 minus equation 3, that's going to give me equation 5, which is going to be 10x plus 5y equals 50. Okay, that's my equation 5. I could also change that. I'll divide through by 5 to give me 2x plus y equals 10. That's my equation 5. That would be a lot easier. Then I'll multiply my equation 5 by 4, and that would give me 8x plus 4y equals 40. And then my equation 4, I'll write down below it, what was it? 7x minus 4y equals 17. So if you add both of those, you will eliminate your y. So you'll have 15x is equal to 57. Divide across by the 15, you'll get 3.8. X equals 3.8. Sub that into equation 4 then. So 7 times 3.8 is, 7.3.8 plus, no, sorry, it's not that at all. It was minus 4y. Minus 4y is equal to 17, which means 7 times 3.8 minus 17 would be equal to 4y, which means that works out as 9.6 equals 4y. Wee bit of working out y equals 2.4. Fire both of those things into equation 1. Let's see, equation 1 was 5x. Where on earth have I got that? 5x plus 6y plus 8z equals 47. Okay, so let's just put those in then. So that's going to be 5 times 3.8 plus 6 times 2.4 plus 8z is equal to 47. 8z then is equal to, and let's just do that, let me just work that out. 47 minus 5 times 3.8 minus 6 times 2.4, that works out to be 13, I got 13.6. My z then, divide that by 8, is 1.7. Okay, right, that's been a lot of work. Let's just check that in equation 2. So let me write those down, what I had. I had x equals 3.8, y is equal to 2.4, z is equal to 1.7. So check it in equation 2. So your equation 2 was 8x. So what I'm just checking here is 8 times 3.8 plus 3 times 2.4 plus 2 times 1.7. Press equals. I got 41. Happy days. That's right. So we'll check it in equation 2. That is right. So my answer, what were the first ones called? Hurricanes, were they? So my answer, a hurricane cost, and it was 3.8 thousand. So it's the profit, sorry, was 3.30. Profit was 3,800. Guana, its profit then was 2,400. And what was my last one called? I forgot his name. Geronimo. Its profit was 1,700. And that's it. Okay, lovely. Oh, there we had it. Oh, there, I could have written that all in there. Sure. Okay. Right, next one. It says the table below shows power in p watts and voltage V in a particular circuit. Okay, it is believed that the relationship of the form P is equal to kV to the power of n exists, where k and e are constants. Verify that a relationship of the form P is equal to kV to the power of n exists by drawing a suitable straight line graph in the grid opposite. Show clearly the values used to correct the 2 decimal places. Right, I'm going to do this here. First of all, I'm going to, I've got P equals kV to the power of n. I'm going to take logs of both sides. I'm going to have that equals log of kV to the power of n. And then using your first rule of logs, you could say that's k times log of v to the power of n. And then you could rewrite that as log of k plus n log of v. That's using your third rule of logs. And then you could write that's log p is equal to n times log of v plus log of k. Now, why I've done that is that's equivalent to your y equals mx plus c. So my gradient is the n. My intercept will be log of k. On my vertical axis, I'm putting log p, because that was equivalent to the y. And on my horizontal axis, I'm putting log v. So I need to plot log v against log p, where log v goes on the horizontal, log p goes on the vertical. So that's what I'm going to do. So here, we need to find log p and log v. And I have worked these all out already, so I'm just going to fire through these very quickly. 1.041, 1.653, 2.097, 2.389, 2.607, and my log v is 0.176, 0.472, 0.699, 0.845, 0.954. Now I've fired those down so quickly, but it took me a bit of time to do that when I was doing it out properly, so it does take a bit of time to put them in. So how we got that first one, for example, I did log of 11, and to get this one I did log of whatever that was, 1.5, and so on. So that's all we're doing there to get them. Right, what the question says, verify the relationship of the form exists by drawing a suitable straight line graph in the grid opposite. This bit here I think is essential. I don't know what marks you get for this, to be quite honest, but and we've got our values done to correct the 3 decimal places. That's what we've done above. Okay, right, we can plot this. Right, I'm going to plot this very quickly. This bit isn't overly important, if I'm quite honest. What is important about you get the axes right way around. So it was log p in the vertical, log v in the horizontal, and when you plotted it, I'm doing this very quickly here. When you plot those points that you had before, very roughly, this is where they are. 0.5. Okay, so I'm just plotting those very roughly from where they were. Right, just to show you I've done these roughly. I'm not even going to use a ruler here. I'm just going to do this freehand. But you would obviously use your ruler in an exam here, so that's all you're doing. Okay, I'm going to sort of cheat with this graph. The next bit says, hence find the values of k and n correct to 2 decimal places. So correct to 2 decimal places is pretty accurate, so you're not really strictly using your graph. But this point here was the last point that they gave me, and this point here was the last point they gave me on each end. So I'm going to find the gradient of this really by looking at these. So you're going back to this table and you're looking at this pair of values and this pair of values. So that's really what you're doing there. I'll highlight these just so it'll make it a wee bit easier to see. So you're using those values to work out your gradient. Because your gradient, remember, gradient is y difference over x difference. But in our case, it's going to be the log p difference over the log n difference, log v difference, log p difference over the log v difference. So we're doing this vertical change, the log p difference, over this horizontal change, the log v difference. And we're using the extreme things. So that was k was my gradient. Am I right on that? K was my gradient. No, n was my gradient. It should have been. N should be my gradient. Yep, n is my gradient. So we'll say here n is going to be equal to, and it's going to be log p difference over log v difference. So that was 2.607 minus 1.041. I'll show you again where I got this. That was 0.954 minus 0.176, which worked out to be, and I'm going to write it as this 783 over 389. We'll give that in a wee second. Okay, so that's what you've got. So that was your n, where n was your gradient. Okay, n was your gradient. And where we got that from then, so you can see that was this one here, 2.607 minus your 1.041, and then over 0.954 over minus 0.176. So that's how we got this value, magically got this value here. Okay, right, we can then put this into the original equation. So my original equation was P is equal to K times V to the power of my n, so that's 783 over 389. And I'm just going to use one of my original pairs of values. So originally it told me when P is equal to 125, V is equal to 5. So let's just put that in. 125 then is equal to K times 5 to the power of 783 over 389, which means we can just divide across and get my K is equal to that. The power of 783 over 389 is equal to your K. So see what your K works out to be. So let's just do that. 783 over 389. And that got me that K was equal to 4.89762. So we'll just give our answers then. K is equal to 4.90 to 2 decimal places. Yes, to 2 decimal places. And then our K, what was our value of n? Sorry, n, remember, was equal to 783 over 389. So let's just do that. 783 divided by 389. Press equals, and that to 2 decimal places, my n is 2.01 to 2 dp's. So let's just put those in. 4.90 and 2.01 to 2D piece. Okay, next part of the question says use the formula P is equal to K V to the power of n with your values of n for values for K and n to calculate the minimum voltage required if a power must exceed 1000 watts. So our formula was P is equal to and our K value was 4.90. So it was 4.90. Yep, sorry, where are we? Yep, 4.90. 4.90 times your V to the power of your n, and your n, our n worked out to be 2.01, and the power must exceed 1000, so 1000 is equal to 4.90 times V to the power of 2.01. So divide across 1000 divided by 4.90 is equal to your V to the power of 2.10. And then if you imagine here, this is a wee bit strange, but if you imagine you had like V to the power of 3 is equal to some number, you would say V is equal to that number cubed rooted. Now you can use this to do the same thing on your calculator here. So here we could just say then V then will be the 2.02 root of 1000 over 4.90, and then let's just do that and see what we get. So calculator, the root button, and so shift and your power button, normally that is 2.10, and then inside the bracket 1000 over 4.90, press equals, and I got 14.010. It's going to be the 2 decimal places for the volts. Okay, your assumption is that the relationship continues in the same way. Okay, right, next question. We are almost there. I think this is our last question, actually, is it? It says here, a gardener fences 5 adjacent plots, each x meters by y meters, with a shared fencing as in the following diagram. The total of 300 meter fencing is available. Show that y is equal to 30 minus 3 over 5x. Okay, your total perimeter is 300. You've got what? How many y's have you got? You've got all these wee y bits available here. So you've got a y here, a y here, a y here, a y here, a y here. So you have got, that's 5 y's, but you're also going to have them up top as well. So you've got 10 y's, and then your x's, you've got 1 here, 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 and here, and here. So that's 1, 2, 3, 4, 5, 6. So you've got 6 lots of x's as well. So let's just divide through by, well, rearrange to make y the subject. First of all, 10y is equal to 300 minus 6x. Divide through by your 10, y is equal to 30 minus, and that would be 3x over 5 as required. Lovely, nice easy mark. Next question says, hence show that the total area of 5 plots is equal to this. So your area is going to be equal to, you've got one of these would be an xy, and you've got 1, 2, 3, 4, 5 of them. So it's going to be, the total area is going to be 5xy. So your total area is going to be 5x times your y, which you just worked out to be this thing. And then if you do that out, your area is going to be, it's going to be 150x minus 3x squared. That's what your area is going to be, and that's what they were looking for. Happy days. Nice easy mark there. Easy 2 marks. And the last part of the question, last part of the exam, find the minimum total area. So your area was equal to 150x minus 3x squared, and we want to find this minimum. So you've got to do your dA by dx, which would give you 150 minus 6x. You want to then put 0 equal to that, which means 6x equals 150. Wee bit of working out, which means 25. And then you just check to see if it's maximum or minimum. Find a maximum total area of the 5 plots in. So we want to check this. If you differentiate this thing up here, you get minus 6, which is less than 0. Therefore, that applies. That is a maximum. And then find the maximum total area. I would just say when then x is equal to 25, your area is 150 times 25 minus 3 times 25 squared. Do that out and you will get 1875 meters squared. And that's us done. Happy days. Okay, so once you complete an exam, just go over it and just check you're working out. Hopefully I haven't made any major mistakes there. That is us done. Thank you very much.